Hello everyone. Uh, Now I'm the only guy starting between you at pizza, so I guess I have to hurry a bit. So my name is Leszek. Last 5 years in working in government. As you can imagine, it was Scala, AWS, Kubernetes. This presentation will have two parts. First, we need to talk a bit about AWS, and then we talk a bit about how Scala can help us developing. In this presentation, I focus on the very recent feature added to the AWS, which is AWS Lambda, which is nothing less than a serverless framework when we don't really have to care about infrastructure. We're just developing code, set up, this is quite convoluted way, triggers, and just run it. AWS Lambda has a couple of runtimes to select from: Node.js, Java, Python, .NET, Go. You can also create your own customs runtimes from provided images. I haven't done it yet. Lambda functions are triggered from quite a lot of services. I will try to show a little bit on the console how easy you can integrate with it. Lambda has limitations. First of all, it's not a continuous service. It can run up to 50 minutes. By default, it can run up to 3 seconds. Therefore, you know already what Bezos want us to do with that. The whole archive cannot be more than 50 megabytes, which creates a bit of problem if we're using any heavy stuff on the Java library. For example, Google Guava adds another 3 megabytes. So you have to kind of work it. However, the good thing, it can run really powerful concurrency. By default, it scales to about 1,000 concurrent executions. It has a couple of interesting features like a Lambda on edge, when it can be delivered directly to the, for example, 5G processing center, and can directly execute right after your call. Therefore, this is the power of Lambda. Because I'm talking about AWS infrastructure, I will use a couple other services, which is probably most of you used simple storage service called 3S buckets, which are storage solution for AWS. The good thing about them is they are unlimited. They scale out of the box. They support about 3,500 concurrent writes, reads. They are unlimited space. Another very often used service is a simple queue service, which is at least one delivery guarantee service. It acts as a buffer in this design. Probably one of the less known services is the Cloud Search service, which is nothing else than Elasticsearch, with quite convoluted way of updating documents there, but very easy interface, a very easy endpoint from the front-end applications when you can start writing and gives you suggestions, search. And the last service I will be using is Amazon CloudWatch, which is just for retrieving logs. All right, what's the exercise about? I will try to present the coding exercise, and hopefully that will go well. I have about 100 text files, short text files, about one kilobyte each, poems, excerpts, yada yada. I have a mapped S3 bucket by Commander1, which is just a simple tool, just to copy something to S3 bucket. And I will hopefully be able to achieve dynamically adding and indexing the content of those files as I go, just by copying the files. For that, I need the architecture. First of all, is S3 bucket, which will be copying the files. There's one note about S3 bucket. S3 bucket is backbone of many services in Amazon. Elastic file system works on the S3 buckets. Therefore, sometimes you might be using S3 bucket without even knowing about this. S3 buckets offer us something which is called notifications, S3 event notifications. Events like a creation of the file, removal of the files, however, also the versioning of the files. If you want to write a proper architecture, when we, for example, want to implement a warm model, when you write once, read less, which is quite often in civil servants, when you have to, for example, store the documentation and make sure it's always there. Therefore, we're creating object lock. After that, after write, object cannot be read. Lots of those functions are provided as out of the box. We don't have to write about them. This is a good thing about AWS. Although it requires lots of knowledge, because AWS is not an easy beast. Once the event is generated, we run into SQS queue. Why? we need some buffering mechanism before writing that to the cloud search. SQSQ triggers a lambda. This is where the magic happens. This is where our function comes in. The function we will read back from the SQS. This is how it's done. So SQS trigger lambda. Lambda then pulls on events from SQS true. This allows us to batch it. I'll hopefully show that in the code. If we receive a so-called create object events, we start reading from S3 bucket. We have a content, we can index it, which then can later load it up. Why do we need SQS here? Why do we not send directly event from the S3 bucket directly to the Lambda function? Because of the batching problem. Cloud search has limitations. One of them is one document's batch updates every second. I will show what the document batch is in a second, so please don't be scared. The couple of limitations like a maximum batch size, maximum document size. However, there's one thing I haven't mentioned yet, is the policies, roles. AWS is a very secure environment. We can very fine-grained define what our function can do. We can define that our function has access to the S3 queue, our function has access to S3 bucket. We can define exactly which events and roles it can perform. In Lambda function, this is something called executive function. An executive function, we have to specify, we can use the cloud search, we can read from the S3 queue. This is quite complex topic. I won't be mentioning that much. If anyone wants, can contact me on that one. All right. I have bits of the code. I think easier if we talk about this by IntelliJ. First thing, whoever worked with the AWS is to write a retry function. Depend on the Bezos smooth, some of the function fails randomly. Sometimes just get 404 without a reason. Retry. Retry everything in the in AWS. That solves most of the problems. This is a fancy way of writing retry function. All right. All Lambda functions starts with the request handler. It's not necessary. However, it defines already handler for us. Therefore, we know what we're invoking for. Entry the function is handler request. There is one gimmick here. If you want to use Lambda logger, which provides us very nice pretty print on the AWS logs, we have to get from context. Therefore, first line of our handler request is to get context. Then we getting input SQS event. We're getting records of that. This is currently unsupported function. However, in the future, AWS is expecting to batch or stream most of its events. Right now, there will be just one event, and that's how it was. And here we go for Scala. Start parallelizing straight away. This is where this is the power of Scala coming. By just 3 letters, we can parallelize the whole substream. If in the future AWS decided to send us more records in a batch, we can right now to parallelize straight out of the box. Another one, deserialization. As I mentioned before, the SQS queue here is used as a buffer and also provides the batches. Here I pre-configured that SQS to pull for up to 10 events. Therefore, we get them delivered at the same time. Right now, after retrieving records from the SQS events, we straight away flatten it out the records. This is our S3 event notification record. S3 event notification record. They come variety of sizes. Here I'm just doing simple check what's the event name for created for removed. Our key in the record is just the file name. It can be more complex. We need to normalize it. I'm just removing all the ASCII, removing all the white space for that. Here here it all starts. To be able to read objects from the S3 bucket, we need to create a S3 client, which is a good thing actually from using AWS client, because you don't have to provide any credentials. This is already coming out of the box. If you're using here, I will scroll it a again. If we're using S3 client, if we're using Lambda functions, all the secret key and key IDs provided already for us, we can just use default client. This is actually a nice touch from the Amazon, if you ask me. Another thing, because how the SQS events are constructed, they internally in the body contain the JSON structure of our events we're selecting for. The S3 notifications are not the only thing we can package in SQS. Therefore, there's structure in the body, which I have to unpack it. Lambda provide us a number of serializers. However, there's an important thing here. We cannot use default class loader. We have to use the one from thread. I don't know why it's like that. It's the common mistake. Once we have our S3 client, once we get S3 client, we can get objects, start reading it. Reading from S3 object is just simple. Get object content, which is our input stream. Because document in search in the search cloud, which is Elasticsearch, has limitations to about 1 megabyte. We're just reading first 1 megabyte of bytes. We're skipping the rest of it. All right. Once we have our data. Okay. There's also another structure here. I forgot to mention. It's about try catch. Events might be delayed. We might already move this object back. We have to kind of try it, skip it if it cannot be read. On the success, we passing another structure. This is a little bit disadvantage of using the Amazon SDK client. Amazon, for the less used functions, we don't really have a proper objects. Therefore, we have to do our own JSON mapping. Here, I'm just using simple map with the type, which is adding object key as the ID fields. As you can see, also I'm also casting them as Java maps, or otherwise the JSON, which is later we'll understand. Something similar happens to object removed when I'm creating a structure, type delete, object key, the same thing. All right. After that, I'm uploading them to JSON. I will show in a second how it looks like, so it's less magical there. Cloud Search client is very similar structure because we have provided the environment variables. We have already provided the secret key and key. We can just default the client, use it. There's a structure in the Cloud Search where we have first describe domains, what we have available, then we can read from them. The Cloud Search provides us 2 endpoints. One is for reading or suggestions. Another one is for the uploading documents. All right, that was the code. The whole thing compiled, it's about 23 megabytes. It's already quite heavy. Most of it is because I use the Google Guava, which provides us JSON, and also I use the Apache Lang3, which is I think another 4 megabytes to that. But you have to keep in mind that functions in Scala are heavy. The limitation of 50 megabytes, I'm already using half of it. All right. How does it work? That's my. I have a couple of views open already. I hope they won't log me out. The most interesting bit is we'll be observing this queue pre-created before. And right now, let's go through it, and I hope it won't crash. I have around 150 megabytes of 50 files, which I'm just copying in. Once those files will be copied, I have hopefully this queue will start to be filling in. Here you go. There should be total around 150 messages. However, they are being processed on the fly. Hopefully nothing will crash. As our messages are processed, we can look for our logs. Creating objects. Let's go further. Please remember that Lambda functions are executing in parallel. Therefore, there might be a couple of logs for the same function. Let's try for this one. Start creating objects. Not yet. Let's try another one. Right, here we go. This is a log message I created when we received the file. This is what we collapsed it to. This is how the closest document batch update looks like. Our type, all fields with the content. Right now we can go for the Cloud Search. And hopefully those files will be there. Here we go. To be filling in, oh yeah, almost already done. Let me check the SQSQ. Yeah, SQSQ has processed all. That was the coding exercise. Deleting works the same way, just refresh. It's about 600 lines of code, which you have copying, deleting, indexing, all of the files. I see you're very impressed by AWS power of AWS. Okay, now I want to point something. The whole exercise, which took me about a couple of days to write, and I started with the bigger files, cost me about $2. And that's it. The cloud search domain, the cost is $25 plus any transfer cost. And that's it. For $25, you have a full managed auto-scaling Elasticsearch. No need for any DevOps. So that's the power of the AWS and a bit of Scala that too. All right. Because I managed to not to crash it fully, we can skip the questions. I had a bit of code, but I think it was easier just to show you by hand. Sure.
Question maybe not related to Scala itself, but I'm wondering, I'm curious, what framework do you use to manage Lambda functions? I mean, whether AWS SAM framework or serverless or maybe Terraform to deploy Lambda function and manage all the infrastructure.
I like the console myself, but Terraform is very good if you want to have a managed environment. Mm-hmm. The way I saw it work is have a GitHub repository with the Terraform scripts. Mm-hmm. Yeah, I think that was the best. Then DevOps engineers created a couple of GitHub actions on that.
Thank you.
Sure. Another one?
Are you using the AWS Java SDK for the AWS thing, or is there a wrapper specific for Kotlin? Because for Scala.
I'm using Java 11 here and the Fudger assembly.
I see that you retrofitted like error handling and try catches on functional type. How easy was it to interface with this Java calls?
You're probably referring to my runtime exceptions errors. It's not fully functional, it's a mix of those two. I'm trying to create the both of two worlds. For example, I'm throwing runtime exception because that quickly kills me the Lambda function if it doesn't work. And at the same time, I'm using the collection operations. So it's just getting the best of two worlds. Sure.
Why Scala for this sort of application? I assume you do this like on your normal job.
Yes, I like the parallelization aspect of Scala. Scala was created like a functional programming. When we start working on the really powerful machines, something like a 64 cores, things like that, there's not really a way to avoid functional programming because how the L2 to L3 cores are synchronized.
Java people avoid it for a long time.
Java people can.
And it worked pretty well.
It can be, but to write something properly concurrent, which won't stop the whole CPU bus, just to synchronize the same bit in memory to every core, there's no other way just to do it functional way, because you have to make sure you guarantee that you'll be using different memory blocks in other cores. This is how the L3, L2 levels are loaded. So each core has a level 2, and all the core in machine share the L3 level. And all of this is downloaded from the big memory. Of course, the access to the L2 core is the fastest, L3 core is the slowest. What happens if you need to synchronize all the CPUs on the same bit of memory? Every core is stopped. Now, this is nanoseconds, but if you're adding it up, well, it makes a difference. The very good example is long adders in Java. Remember? So there were atomic long and there's long adders. Why? Because long adders were synchronizing on read and write, and long adders are synchronized only on read. So if you write, and then we need to synchronize on read. And this is probably you don't see on your laptop when you have like maybe 8 cores, or maybe this one is a big one, so maybe it has 12 cores. You see only have like a 64 cores times 2 because they have a HTC link. So you have 128 cores to stop in the moment. And this is not to be visible at that level.
Okay, so I guess I was just curious, like,
oh, sorry.
if you've done this sort of like data processing stuff, or if you also like exposed maybe like HTTP endpoints using lambdas, and if you faced any sort of issue, for instance, the cold start problem.
I have written Lambda on Edge, so but the cloud form only once in my life. It was just for the authentication. So this function is just run and go back very quickly. I think that the execution type, because we also use DynamoDB, was like less than 1 second. That was the idea of this. So you can run thousands of Lambda concurrently, quickly go to DB2, go back. So then you're skipping the whole. Then you don't need to queue it because they're executed in parallel. You just need to queue it. It's not your problem then. So that was the reason.
It can become your problem if you keep spawning up new lambdas. It takes seconds to start. It doesn't matter in this case because you're doing background processing. But if you, for instance, if you want to serve a REST API using Lambda function,
a bit yes. It's not for the continuous use. For that, we need a proper instance of Spring Boot or something.
There's also GraalVM option now. GraalVM from.
GraalVM. I haven't used this one.
So it's a native compiler. It's any Java-based language can be compiled to native binary.
Okay. I don't know if you can write it on runtime. I'm pretty sure you can because you can.
I think Scala also. Scala native. Yeah, Scala native.
Right.
You can compile it to GraalVM. It's just super fast. Cold start times.
I don't know if. Oh yes, please.
And regarding lambdas, I know I haven't tried, but maybe you heard there is a framework, Kits, if I'm not mistaken, which idea is to create functional Scala code, which then compiles to JavaScript and can be run as a Lambda function on Node.js runtime.
I haven't seen that one. I haven't used that one. Most of my Lambda was Java and Scala. Any more questions, maybe? Or we go for pizza? Pizza. Okay.